Well, hi, good morning. Thanks so much for joining me in my shop and look at what's in here. Oh my God, this great big 65-pound radio is back in here again. Wasn't my plan to bring it back here, but it's here. So why did I have to bring it here? Well, here's a bit of a story. So I brought this radio into my shop a couple of days ago or a week ago, only because it was convenient at that point. It was already out of its usual spot, and so why not bring it in here and just check it out. Well, I checked it out. I discovered a problem with it, which was back here, the antenna relay, which I had to correct. I wanted to make sure, that the key killer capacitor and a couple of its brothers had been changed in this radio, so I took this IF strip out, and yes, capacitors were already changed, so I tested one vintage capacitor in the set at that time, and it came back with a bit of a leak in it, but not enough to prompt me to start doing some wholesale capacitor work on a radio that I know is already working. So that also allowed me an opportunity to do a proper job of adjusting these two adjustments. The proper job requires some specialized in the manual. A certain equipment and method is specified for adjusting this guy in particular, and that's the piece of equipment, and I have the all the necessary steps, so I went ahead and did that. What didn't come out, and then I posted one video, chopped up video of me working on this radio, compressing 4 hours into just a couple hours, because I spent hours looking for why the radio wouldn't work until I found this relay problem. So it's back in here now because in its operating position and in competition with my other fantastic radio, the Hammerland SP600, this guy and the SP600 started out neck and neck, receiving shortwave stuff, having a great time. Towards the end of the evening, though, I noticed this guy wasn't producing so well anymore, and my Hammerland was hearing stations that this thing didn't even know was there. That's not normal. One of the things I didn't do with this radio last time it was in my shop was an alignment. The reason is a couple fold. One, the radio largely works. Two, I was able to measure its sensitivity at 1 microvolt or less. So what is there to be gained from doing an alignment? And lastly, look at it. Oh my God, you want to try to align this thing? But what didn't come out in the video is that the wrong tube is sitting here. So this is supposed to have a 6DC6. The tube that's in here, I'm going to verify this, is a 6DK6. So a 6DK6 is not a good tube to replace a 6DC6. I'm going to verify all this stuff. But I knew the wrong tube was in the radio. I do not have a replacement. I do not have a proper 6DC6. At least I haven't found one yet in my meager tube collection. I have a lot of tube substitute books here. I have enough books on substitute tubes that I have substitute books on substitute tubes. Look at them all. Oh, we got one twice here. 3 times. I got the same book 3 times? No, it's slightly different. I looked in these books. I didn't find any reasonable substitute, but I've been told, and it shows up in documentation, that a 6BA6 is an okay replacement for this. 6DC, let me just check one. 6D, maybe I was all wrong about this. 6DC6. So here's the possible replacements. 6AW6. I probably have a bunch of those. 6BZ, 6CB, 6CF, 6DE, 6DK. 6DK, it's right there. Oh, am I ever wrong about all this? And what did I do with the tube? I've thrown it away already. Well, how do you like that? So you know what? That's the problem. I got too many substitution books. I must have grabbed the wrong one. 6DK6. Now, what about a 6BA6? Doesn't show up here. 6BH6. There's quite a few replacements for that one tube. 6DK6. When I looked at a 6DK6 in the tube in the tube manual, the RCA tube manual, they didn't seem to be very similar. 6DC6 and a 6DK6. Let's see what this book says. 6D. I guess I should just keep looking in these books until I find whatever I want. 6DC6. Same list. 6DK's there. It's the very same list. That's got to be the same book. How about Sam's? Let's try Sam's number 21. 6. But no 6BA6. As exists in this other 6DC. There's just too many letters in the alphabet here. 6DC. Oh, it looks like exactly the same list showing up here. Well, it looks exactly the same. It looks like it's almost printed out of the same book. 6DK6 in there. It's the same. It's the same. It's the same. Why didn't I find this the first time? What did I do? Crying out loud. Oh. So what I did. This is a really short one here. Excuse me. In order to test the tube, I decided to set up my tester for a 6DC6 and stick the 6DK6 in there and test it. It came out quite low. 6D. That's not even going to be in this. 6DC6. 6BZ, 6CB, 6DE. Cover. Well, what we're going to try here, I'm going to try to pick a good 6BA6 and set up my tube tester for a 6DC6, stick a 6BA in there and see what happens. Let's give that a go. Now, a person could spend their entire life reading about this radio on the internet and never get around to actually using it. So there is a ton of information and comment on this radio, and it's fantastic actually. I'm not complaining. So there's quite a discussion about this first tube, the 6DC6. Seems like the opinion of some is that it's actually not really the best tube for the radio, even though it's the one that's specified for the radio. A better choice is a 6BZ6. Lucky for me, I got a bag of 6BZ6s here. I also have a bag of 6BA6s. So what I'm going to do, because I understand a 6BA6 is also a suitable replacement, I'm going to check into these, check the tube base layout, look at my tube manuals, just get some comparison in my head about these three different tubes. Then I'm going to try to find a couple of good tubes in a 6BZ6 and a 6BA6 that are really good, tested as themselves. I'm then going to test them as if they're a 6CD6. That's what the radio is designed for. And we're going to try all these tubes in the radio and mess around, and that should pretty much blow my day away. So that's the plan. So the first thing I got to do is get a couple of known to be good 6BZ6s and 6BA6. Okay, so 6BA6, no, 6BA6 tubes cannot be popped in where a 6DC6 was. The base arrangement is different, so that's false. No 6BA6, but 6BZ6, the bases do match. They're listed in my substitution book, and I found a comment from a user of this radio saying this is a far better tube to put in the front end than the original 6DC6. So what I've done here is I've tested three of them. They have numbers on them, 1, 2, 3, 1, 2, 3, and they're all quite different. So the first one is kind of middle of the road. The tube tests at 1700, the number 1700, and it needs to be above 1300, or you should reject it according to that tester. So it's a little ways above the reject point. The next tube is way above, so 1700, 2100. This is a much better tube. And the last tube is really poor. It's actually below the rejection point. So I've got a bad, a medium, and a good. Excellent. Three excellent tubes to stick in this radio and find out what happens when I do that. Now the tube that came out of there, 6D DK6, which is somewhere around here. I think it's here. So my tube tester I'm using does not have settings for this particular tube. I'm sure I could find them in supplementary publications, but I'm not going to do that. Instead, what I'm going to do is I'm going to set up the tube tester for a 6 DC6. That's the tube the radio is designed for. Now I'm going to run all 4 of those tubes through it as if they are 6 DC6s. The assumption here is the radio's voltages and other things in the circuit around the first tube are designed, of course, for the tube they intended, the 6 DC6. I'm going to try to mimic that with the tube tester. You really can't do this, okay? But I'm going to try it anyway. I mean, the tube tester is not a radio. It doesn't operate tubes the way a radio operates tubes. It's doing something different with them. So, you know, this is just kind of for fun. You know, what is it I'm doing that's not just being done for fun anyway? So, let's start off with the tube that was in there. Oh, I gotta set this thing up first. Okay, I'm gonna stop and set the tube tester up, and then we'll give the 4 of them a try. Actually, I'm gonna run the video while I do this, because the tube tester is currently set up for a 6 BZ6. I'm gonna change it now for a 6 CD6. Well, what kind of change is that? We're gonna find out. Shouldn't be much. 6 CD6, so 6.3 filament, 4 signal level, 20 L. So there's a little bit of a change. A little more bias voltage. 20 L. 51763, these shouldn't be any different. If they are, we're in big trouble. No, they're fine. 35, so this changes a little bit too. This is just a sort of calibrating the meter is really what this control is doing. D, yeah, so it's pretty much the same, slightly different settings. Okay, so now we're going to test all 4 of these tubes as if they're 6 DC6s when they're not, actually. Here we go. So just make a note of how much this tube is just glowing like a son of a gun here. Yeah, that's really quite bright. 6DK6, no doubt about it. Okay, so that's the first tube. It basically failed in this test. So we're going to try now tube number 1 of the 6 BZ6s. This is the middle of the road tube. Middle of the road tube. So I wonder what would happen if I stuck a 6 BA6 in that radio by accident. I wonder. Could be absolutely nothing happens. Could be some resistors burn out. I don't really know. For sure. Okay, we're ready. So this guy's testing. It's going to go up to about 1500 in the end. It's still warming up a bit. We're going to call him 1500. So I'm going to put the 1500 here. Slightly lower than it tested when it was tested as itself. I don't think this is that much of a surprise. 1500 is a pass for a 6 DC6 in this tester. 1300 would be a fail. Tube number 2. So this one tested really good as itself. We will now see how it does as an actor. Still warming up, of course. Looks like it's going to get all the way to 2000. When it was tested as itself, it was 2100 on here. Just under 2000 now. Call that, we can call that 2000. It's still creeping up a little bit. Let's call it 2000 because I like a nice, easy number. So we'll put 2000 here. Just slightly less than it tested as itself. It tested 2100 instead of 2000. Very reassuring that I don't really have any doubt at this time that putting in this tube is going to be a better choice than what was in there. That's going to force a little bit of realignment. That's a big word for a little thing I have to do to the radio after changing this tube. Okay, so this is the weak one now. Came out as a reject. No shorts. No show. So, interesting enough, I had trouble making heater contact with the same tube. There, I'm watching the green light. Judge it. There we go. Now it's warming up. Come on. It's testing pretty bad. It's starting to come up. I think we got contact problems here again. Yeah. So there we are. So now it's testing 500, 600, 700. And it tested 1,000. That's interesting. 700. 700. It's interesting because the worse the tubes is, the worse it tested. So that's good. So now we have 3 interesting tubes to put in this radio and mess around with. We have 4 actually, because I still have the original tube, which is where we're going to start. So what I'm going to do now is I'm going to set the radio up. I'm going to put its original wrong tube in there, get everything set up and stabilized, make some kind of measurement like a sensitivity measurement. Then we're going to start popping tubes back and forth. In the background, something more may have gone wrong with this radio because it appeared to have great sensitivity at the start of my listening session, and after an hour or two it seemed to be quite reduced. I don't have the instrumentation at my listening post to really check that kind of stuff out. And here it is in here. Okay, it'll take me a little while to set this up, I'm sure. So while you're listening to the output of the radio, no, not really, just listening to audio noise in the way I have things connected. We can't hear this radio at all. So the little bit of noise you're hearing is just coming from my shop audio. For some reason I can't fathom it out. It's not the radio signal. The radio's operating. Its own output is so low we can't hear it. I think that's what's going on here. It's below this noise. And why is that? I think once again that this relay has failed to connect. So I'm just going to operate it a few times here and see if it's just nothing happening, is there? Okay, let's see. I can feed a signal into it with a signal generator that I know what is going on. At least I have a better chance of knowing what is going on. So let's do that. Feed a signal here. Up around 9 megahertz is where. That's good. That's where I got the radio to. Oh, that's interesting. So, okay, hold it right there. I've discovered this before. Sometimes putting the ground on isn't very helpful. So this is all the volume she's got. Did I do this right? I did not do this right. Let's try this. Oh, there we are. How do you like that? Just turn this down, turn that up. Now I think we're hearing the radio, for crying out loud. Let's see. Oh, maybe not. I'm disconnecting and reconnecting the antenna. It doesn't seem to care worth a hoot whether it has an antenna or not. I got the volumes up now for sure. Yeah. So that's sort of the shop hum. And there's the radio coming up. I turn the volume up high enough. Maybe we can find something here. So, what do we decide? Do we decide it's the antenna. Relay. Ow, that hurt. That was a little loud. Carry on with the signal generator. I think, I spent a whole day in this exact situation before discovering it was the relay in here. A whole day of getting frightened that this radio was never going to work again. Okay, signal generator's in. We're pumping in a signal at just under 9 megahertz here. Just under 9. No, it's got to be above 9. Let's just go see if we can find it here. Putting out this radio could easily pick this up. Hello, hello. So if the relay has failed to operate, I can still get some signal through here if I just pile a bunch of signal onto the antenna thing. Some of it's got to get through, I would think. Piling on, pile on. Here. Yeah, it's calibrated. Put it out. Not a thing. Not a thing. Not a thing. This is why I would never suspect it's that relay. Maybe. I think I'm gonna have to take the relay back out. I think I'm gonna disable the relay and make a permanent connection in here. I don't care about the relay. It's not of any advantage to me at all. Ooh, is that true? The calibrate function depends upon the relay operation. I think the idea there is when the calibrator is clicked in, you're disconnecting the antenna. Get it out of the way, and plus don't send your calibration signal out the antenna. Why would I care about that? Maybe I'd like the calibration signal to go out the antenna. Get to other radios. Calibrate other radios with this one. How often have I calibrated this radio? Virtually never. I have other ways to calibrate it. I have frequency counters and stuff, so I don't need the calibration thing. So why not? I just wish we would get some strong evidence that that's the problem. What else could it be? Just before I go and waste a pile of time. I was just using this radio, so. Oh. Okay, so the RF gain was way down this way. Not way down, just down a wee bit. Probably knocked it on the way in here. This is on automatic gain control, and the radio behaves like this. How does that work? I would have thought this doesn't do much. There are no AGC in this radio. We will find out. Let's give it. Let's find this guy. 915. 91. There we are. Hey, why not? It is the same wire. What? Wait, don't lose your mind. 9, let's set it to 9.2. Okay, up from the signal string. She's dead. Dead as a doornail. I'm right back to where I was with this thing. Well, I'm going to have to go after that relay. I'm going to have to. I have the feeling it's not the relay. I'm going to get this apart. I'm going to make a permanent attachment here anyway. And then that will never be the problem again. I'm going to do that. Okay, got the relay out here. There's other ways to disable this relay so it won't operate. You just cut one of the relay wires down underneath. But I remember the look of the fixed contact, the one that doesn't move in here, just looked terrible to me. And I wouldn't hold out much hope that you can ever get this thing to be reliable in the long run without really going at it. Let me just find my other camera here. Where are you, camera? What are you looking at here? So I'm supposed to look at that and figure out where the camera is in my own shop. Move stuff. It's not there. There it is. There it is. Let's take a look here and see what we got. So, I mean, it's going to look like it's in contact, but sorry, the focus is not there. So I want to make this a permanent contact in there. Right? Just get in there with a soldering iron. That doesn't sound like the best idea. So I see that it's like, it looks like it's integral here. Like this rod, the contact, the part that doesn't move, the big part there, it looks like it's attached directly to this little tiny jack. There's nowhere to solder. That's what I'm looking for. Something I can solder to. Try to solder right on that thing. I don't think that's going to work. Uh-oh. This is not quite as simple as I thought. How do I try to strap it in there so it never moves? That's crazy. If I solder that in there, but I leave these relays going, they're going to keep trying to push this thing every time I turn the set on and off. Disable the relay somehow. If I get that plastic piece out of there, that'd be great. But I'm not going to be able to do that. Oh, the simplest things. This goes to a crummy connector on the back. I have the proper connector to go on here, but it's just not worth using. And then you're supposed to have like there's two leads in here, and there's two reeds in there. I have to solder both reeds, and they're way back there. So we have the other input for a whip antenna or a wire antenna. That's really not the best input to use. Huh, son of a gun. I thought this would just be a snap. Snap, get it? Snap. I'm not the only one to face this problem, I'm sure. Well, you're dropping some solder on there. I don't like that idea. I have to disable these relays. I just disable the relay and hope the thing works. Why don't I measure it? Should I measure it right now? The resistance through there. Let's try that. I don't know what else to do right now. So let's do something. Trying to measure the resistance of this thing is a little tricky because as soon as you touch it, you're mechanically affecting it. Check the meter here. Okay, now I'm going to touch the reed. Let's call it a reed. Okay, and now I'm going to touch the contact point. Oh, look at that. Now, what is it? Is it this that's not making contact? So if you make contact with the stationary contact, it's there. 0.1, that's going to be a 0, I'm pretty sure. 0.1. So it's okay right now. That's not helpful because the radio's not working and this is okay. I want this to be okay. So disable the relays. and leave this. Let's you know, really what I'm finding here is there doesn't appear to be a problem here right now. Why am I doing anything to it? Can I leave it open so I can fiddle with it and continue on? Okay, ready for another try on this radio now. We're all set here. So it's on AGC. I'm going to apply the power. The relay will not operate. Oh, wait, no power to apply yet. Okay, let's try that. So the audio's up a bit, that's why you're hearing a little bit of noise. Okay, here comes the radio. Okay, so once again, we are tuned to 9.200, 9.2. Nothing. Oh, there's something else. Here I am again. I'm going to do another whole day of nonsense here. Laughing, but I shouldn't. Is that coming from the antenna? Take off the antenna connection. Sound's not coming from the antenna. Well, I'm here to experiment with tubes. I'm going to try a different tube in there. Just can't imagine that is going to help. But let's give it a try. Anyway. Oh! Tube wasn't in the socket. Tube not in the socket. I don't think the tube was in the socket. It just fell out when I pulled it. How could it not be in the socket? Oh, it's ice cold. Oh, for crying out loud. What did I do? I stuck it in there and never pushed it down? My gosh. Always, you know, if you're going to take on some really big step with something like this, better be really sure it's worth doing and you haven't done something stupid. At least I better make sure of that. Okay, let's try it again. Let's try this again. Hello. This time it's all going to work because I was dumb and never had that tube in. What a dumb. Well, that would be actually a thumbs up. Sounds any different? Sounds exactly the same. We're at 10,200. 10,200. Can't be there. Gotta go to 9,200. Nothing. before I plug it in. What could have happened here? Me, I could have happened. I'm going to have to go through a procedure that's in the manual for troubleshooting this radio, starting at square one and moving your way forward to try to track this down, I think. We got another tube I never stuck in. Right. These cables are in. Ooh, that didn't sound so good. Okay, I think I'm ready for my tube experiment. I've spent most of the morning just getting the radio to work, and in the end I had no clue that there was anything wrong with it at all. I think this was down, just enough to fool me. Okay, so did you see the meter jump up there? So I'm feeding the radio with a signal. We will listen to it now. Doesn't sound like much because there's no modulation, but if I flip on the modulation, there you are. The signal I'm feeding is coming from the signal generator. It's pushing this meter up. You notice I have this red terminal here and a white terminal here. These have both the AVC voltage on it and the diode output on each one, on one or the other. So this one here, we can put the voltmeter into this. See my voltmeter go up over here. So this is now showing essentially the same as this. This is just a better meter to look at. If I tune the radio, you'll see these two meters now work in conjunction with it. So this should allow me to get a fairly precise measurement here, switch tubes without touching anything, and see what the difference is. So right now I have the good tube in there, the good 6BZ6. So I'm going to make a note here. Yikes. Things are getting a little messy on the bench. So we have the good 6B6, good 6B6. Now I've got this high enough, obviously, AVC voltage is developing. I think that's okay though. They can go a lot higher than that. This is 6 volts right now. So I'm going to write that down. 6 volts. Make sure the radio is tuned. Can't be tuned any better. 6 volts. 6 volts, 6 negative volts. Now I'm going to take that tube out. I'm trying not to burn my fingers doing it, and we're going to put in one of the other 3 tubes. Now, there is an adjustment that is supposed to be made to the radio every time you fill with this tube in particular and a couple others, and that's the adjustment right here, the gain adjustment, which I guess is compensating for variations in the gain of the first tube. Okay, this might make a pop in the speakers. Let me turn the sound down while we do that. Okay, so I'll set this one over here and pick the next one. So we should probably put in the original tube. Can I even find it here anymore? I let my bench get a little too messy here. What did I do with it? So these are the 2 other BZ tubes. Yeah. Okay, let's go on with one of these. So this is tube number 1. This is the average one, or the middle of the road tube. You know, I'm gonna kill the power just briefly while I do that. Oops, bang the microphone. Okay, tube's in. As soon as it warms up, we should be right back. You see this coming up over here. It's an unmodulated signal, so we don't hear it. Oh, we really don't hear it. Oh, I turned the sound down. That's right. You know, it was a mistake turning the sound down. I should have left it alone. And make sure the radio is tuned fully. We're watching this meter. Basically, exactly the same reading. 6. So this is a representative of the strength of the signal coming out of the IF. And that's representative of the strength of the signal going through the whole radio. Okay, that's kind of surprising in a way. I would have thought you'd see a difference. Too hot. Pop. We'll put in the other number 3. Keep moving these tubes around and losing track of them. Number 3. Number 3, this is the really weak one. So we found a good one and a almost worn out one. Kind of seems to work the same. Let's see what a real weak one does here. Oh, I'm going to turn off the radio briefly. In you go. Left the volume this time. I guess there could be some differences in the amount of hiss, but here comes the meter. In this case, it looks like it's going to stop around 5 volts. Let's listen. Let's check the tuning. Tuning, I don't think the tuning should be different at all. I don't think it's different at all. So I'll make a little note here. This came out to minus 5 volts. So there you go. Weak tube. There's some evidence of it being weak, but which you can't hear the weakness, I don't think. This would be 5. So here's 6. Now I'm going to find that original tube. It can't have gone far. It can't have gone far. Get pulled under here. There it is. I see it. It's hiding down under here. So this is what was in there, 6DK6. Okay, so I'm going to pull this tube out. Not very hot at all. And then we'll put in the original tube that the set was running with for all these years. So this tube tested about the same as a 6 DC6 as the last weak 6BZ6 we just put in there. So maybe we'll get a minus 5 out of this. There it is over there. It's a minus 5. Minus 5. Now, the thing is, there's an adjustment here. I'm just going to turn it and you can hear and watch what happens. This is the gain adjustment. So you wanted 6 there, now you got 6. The word on this adjustment is if you don't get this right, the radio is either insensitive or way too noisy. The actual setting of this requires a fair bit of effort in getting the signal generator set up and other stuff, so I'm not doing that right now. The highest we can get there is minus 6. Set it back where it was. It's about here, minus 5. Okay, I'm going to put the good VZ back in. That's number 2. Here it is, number 2. And this is probably the tube that'll stay. Okay, power off. Watch the meter. Tell me it's going to stop at 5 now. No, it's getting up there, 5.5. Turn the radio just a bit. Down from here. So, well, it's 5.5. The reason for that would be, well, I didn't put this on. I can't possibly change it, can it? Oh, I fooled around with the gain control. That's what happened. Duh. I shouldn't have fooled it. Okay, but we know from other stuff that this is the better tube. There we go. Still, so not a huge difference. You know, doing this anyway. Not a huge difference. Well, a couple things now that I have the set in here. A couple things I want to do is I want to measure the sensitivity on every band. There's like 32 bands in here or something. Measure the sensitivity on every band as carefully as I can, because just in messing around, it appears to me some bands are much less sensitive than others, and that suggests a whole alignment issue. I did do something with a slug here. I never bothered trying to do an alignment, and all that was because I knew the wrong tube was in here, or a less appropriate tube than what could be in there. So maybe it's alignment time. But the big time right now is it's lunchtime. I will think about this while I chew my nut. Okay, so I finished doing all those measurements. Let me just get the results here. All these numbers here. This is showing the AVC voltage developed on each band according to the meter over there. When I set this to exactly 100 microvolts at the generator, which hopefully puts a consistent voltage on the terminals of the antenna, making this test quite valid. So you get a low of minus 1.5. That means the IF output's a little weak. I get a high of 4 up here on bands 11 and 12 megahertz. Double check this after doing the whole thing. Yes, this came back minus 4, so I think it's quite a valid test. The top band, 32, I got a 0, even though in the headphones I could hear the signal generator, so I know it's working. It's quite weak, and the band change control didn't feel like it made it all the way into 32, but then I'm not listening to 32 megahertz with any regularity. This is me attempting to draw the shape of the response based on listening to it and tuning through the signal. I started noticing that things weren't exactly smooth. So in some cases, like I got one here, it seemed to have a number of peaks as I tuned through. And here's one that looks like it's squared up a little bit. And then these ones sounded much more normal, just up and down. And this one sounded like it was squared up too. So you can align these radios to produce a more of a squarish response by staggering the IFs like this, and you can get a bit of a flat top on here if you want to do that, or you just do the standard tuning like that. Could be various people have done various things, or the radio's just fallen into this state. Now, the one thing I did notice, did you notice? There's no readings below 8 megahertz. Yeah, because there is nothing below 8 megahertz. The radio's not working below 8 megahertz. So that sounds like one of the converters not working, something like that to me, because it's a whole group of bands. And I haven't studied enough about how the frequency conversions take place in this radio. There's potentially 3 different conversions going on in it. I suppose maybe in the higher bands you get more conversions or something like that. So, or maybe below 7, one particular converter is working and the others aren't, or something. I don't know. I don't really know. But there's nothing there. So there is a test for this in the manual. The radio has a couple of clever troubleshooting features. One is you flip the set into standby, and what that does is it cuts the B plus off from all the tubes. No, not all the tubes. It leaves the oscillators oscillating and rearranges the circuit. Either it just happens that way or they do something more to rearrange the circuit. So there's a test point available under this mode, and you can look for a voltage on the test point. Voltage proves the oscillator's oscillating. The test points charts are here. So we see there's 1, 2, 3 test points for the 3 oscillators. There's another one here I don't quite understand, so maybe with I don't know. But anyway, this one E209 has an asterisk, and it says down here, to obtain the meter indication at the test point E209, the receiver must be tuned below 8 megahertz. So I set mine to 7 megahertz. I'm going to check that test point right now. The test point is a little tricky to spot. Oh, let's see if you can see it. Yeah, so you look down past this tube, and you see a white thing down there, and right beside it says 6023. That's not the number I'm interested in. The one I'd like to read, you can't read. It's up here, down below, but it's just out of view. It says E209. So I'm going to stick my probe into that test point, that white circle right there. See what we get. What do we get? If there's any other special circumstances for this test, like the way the radio is set up, I don't think it matters much. So the meter is set to 15 volts, and we're looking for a voltage on the E209 between 4 and 6, minus 4, actually between 4 and 7. Minus, so it's 5 volts now, full scale. And we'll go in there. Okay, we're in. So first of all, the voltage going the wrong way. You can't really, it's a little hard to see this. It's still in contact. Voltage gone the wrong way. So actually getting a positive voltage here. Instead of a negative 4 to 6, we're getting a plus 0.1 or something of that sort. Just make sure this is really in there. Yep. So what that tells me is the oscillator is not oscillating, according to that test. Now, I've been exchanging emails with someone who's working on exactly the same radio at exactly the same time. We've been sort of sharing our pain. Well, mostly I've been sharing my pain. This individual has told me that typically that problem can come from a loose crystal somewhere in this radio. A loose crystal somewhere in this radio. And I banged it around, moving it from its normal living spot to here, and probably knocked something loose. So there's just a huge whack of crystals up in this area, I believe. I got to read up on it. Maybe they're under here. Maybe they're under there. I shall find them. Okay, after a quick read on the internet, I think this is where the crystals are. Okay, now we're going to lift this up. There it comes. There it's supposed to come. There we go. There's all the crystals. This must be heater contacts here. Now, so one of these crystals maybe, oh, it doesn't look loose. Which one would it be? It would have to be the one related to the 17. Oh boy. I'm going to have to do some more research to figure out which one of these is which. Unless it says on it somewhere. Yeah. Got to read up on this stuff. Okay, a little bit of research in the manual, and this is the correct crystal, and it says right on it 17 megahertz. So what to do? I'm going to pull it out. Set's not operating. Pull it out. Ooh. It's really holding on there. What's holding on so hard? Oh, that did not sound very It looks pretty good. Sometimes they say there can be corrosion on these pins. Well, maybe. It says 8/56. It's almost certainly August 1956. Guess I'll just seat it back in. I might do it. Okay, now we're going to test the radio. AGC. What do we got on the back here? We've got the signal generator connected. Now we do. Okay, the signal generator is up at 11. We want to be fooling around 7. Bit by the fan there. 7. Okay, so we're fooling around 7.5. Let's go. Okay, somewhere around there. Switch this guy on. Headphones. Volumes. Okay, we're up a little bit. Here it comes. And we're on a band that doesn't work. Or does it? So first I want to find that out. So maybe I fixed it already. We're at basically 7.5. Here we go. Nobody home. Okay, so we'll try wiggling the crystal a bit. I don't want to do too much to it. No, this is not the place where the problem is. So I think the next thing to do is to check the pin voltages on that tube there. Where? I think I gotta check this one for voltages. It's a 64, yeah, that's one of the oscillator tubes. Okay, power down. Gotta put a tube extender in here. This is, I may not have tested this particular, oh, well, that tube looks bad. It has a whitish color on it. Huh. Let's see. I think it's just dust. Oh, look at that. I think it's a bad tube. Well, I tested all these tubes. I think it's a bad tube. Should we even bother testing that? Yeah, why not? Let's see. Only you don't have to test it from way up there. You can test it from down here. So it's almost certain this tube is defective. It certainly looks like it's become gassy. And maybe I manhandled it at some point or something like that.
6C4. I'm pretty sure I tested all these tubes. 6C4, 6.3 to 20H, 3076P, 3076P, 5100, 44, F, P1 and P2. So there's P1, P2. Oh, that's right. There's the plate can be accessed from two different pins on this too. So the tester tests both access pins. Okay. Doesn't seem to be heating. That could just be contact problems here. GM test. Okay, I don't think it's heating. So I'm watching, this is not activating at all. Wow, this tube just blew up in 6 different ways. Got gassy and the heater burned out. Oh, there was a slight darkening here. Not much. I think it's a dud. I mean, I think it's a dud in so many ways. It's a dud. Time for a new 6C4. Okay, got a alternate 6C4 in there. Supposed to come up to 1430, which would be, well, it's almost halfway. So we're over halfway. We're close to 16 as opposed to 1430. P1, P2. It's an oscillator tube involved with a crystal. I'm sure that's good enough. I'm sure that's going to work. Okay. We'll put this in the radio. See what happens. Oh, if every radio repair were this easy. Okay, I'll go in. Well, maybe I'm speaking too soon, right? Tube's in. Let's throw the cover on it. Now we'll switch on. Sound should come up. I forgot to put the cover plate on. The antenna box. What's our volumes here? Well, it doesn't sound like it sprung to life, does it? The radio sounds kind of duh. We're at 7,500. That's still nothing. Voltage check on the test point. Just knock down those voltages or volumes so we're not listening to that. So we're on this band. The test point should be producing
between, what's it, 4 and 6 volts negative. We're on the 5 volt positive right now. I should see it go backwards. Goes up the same as it was. 5 volts. So actually it's a little higher. 1.5 volts, so we're 0.6 volts. Let me just change bands here. Oops. Nothing changing at all here because it's not turning on. So I'm just going through the, oh, where am I, 11? I went the wrong way. Okay, here we go. Going to 7. Nothing. Going down a little bit. Just some sounds in the headphones. What happened? What has happened? It's really a shame. Check the tube voltages. Oh my gosh, what have you been looking at all that time? Yeah, I'm going to have to put in the tube extender and we'll check the tube voltages. You know, I've got the radio running on reduced voltage right now. Where are we at? Ooh, too low. 70 volts. Too low, too low, too low, too low. Now it sounds like it's working. Big mistake I was making there. Okay, so we're on blowing my ears off. Oh, that sounds like it's working. We're at 5.57. Let's go down there. Bingo. Okay, what I'm going to do is I'm going to check the sensitivity on the rest of the bands now that it's operating. And finish my chart here. Bad tube. Bad tube. Okay, the result of that effort is kind of interesting, but as usual, I'm not quite sure how to interpret it. So 8 megahertz and above, we get very similar AVC voltages. 3 volts, 4 volts, 2 volts, you know, up and down. Is this indicating alignment variations along here? It could be. Could be some of these bands are a little better aligned than others, maybe. I don't know for sure. But they're all working, and, you know, volume control can compensate for a lot of stuff. But then when we switch to the below 8, so what I did here is I had to repeat the 8 measurement, because I originally did that like an hour and a half ago. I can only get 2.4 this time. So you compare the rest of these to the 2.4, and then you're comparing them, you know, comparatively. Follow what I'm doing, hopefully. But the fact is they're all really low. Okay, this one's not. But 0.5, 0.5, and 0, 0, 0. So no AVC voltage developed on band 0, 1 megahertz, 2 megahertz, 3 megahertz. They're working. I can hear the signal generator. It does sound weak, and you get no AVC voltage developing. So I gotta think now whether, you know, is this all alignment stuff? It could easily be. This set may not have been aligned since 1962, for all I know. On the other hand, my buddy may have aligned it, the fellow who gave this to me, who changed the key capacitors in here, and he may have aligned it. But even that would be 30 years ago, 20 years ago, long time. So I got to give that some thought before I jump into it. So big finding today, dead tube. That's the big finding today.